Okay, so I've put together some practice questions that will help you in the exam. In a later video, we'll go through some actual past paper questions. But the question says, so an object is placed 10 centimeters in front of a concave lens of focal length 5 centimeters. Sketch a ray diagram to represent this information. Well, I'm first of all just going to start off by highlighting any keywords. We've got placed 10 centimeters. So that's going to be my U in front of a concave lens. So I know that a concave lens, I just need to remind myself that has a negative focal length of focal length 5 centimeters. So that's my F. So let's just write those down. So U is equal to 10 centimeters. F is going to be equal to minus 5 centimeters because it's a concave lens. Okay, this is a really key point, and it's often where mistakes come from. Now I want to sketch my ray diagram. So I start off by drawing my principal axes. Draw in my concave lens, draw in my focal point either side of the lens. So my focal length is 5 centimeters. Okay, and then I need to place my object, but my object is more than one focal length away. So that's my object, and that distance is 10 centimeters. Let's draw in a parallel ray, trace back to the focal point, it gets diverged. Then let's draw our unrefracted ray through the center of the lens, and where the two rays appear to meet, so they don't actually meet, therefore they form a virtual image. And that will be my lens diagram. Okay, so the next part of the question says calculate the magnification of the image. Well, I know that magnification is either equal to negative V over U, or I can use M is equal to image height over object height. And again, let's not forget that negative sign. Well, in the question, I'm actually given U, but I'm not given image height or object height. And I need to find V. So this sort of indicates I'm going to have to use the formula on the left. Well, in order to find V, I'm going to have to use my lens equation, which I know is 1 over F is equal to 1 over U plus 1 over V. Now, I'm going to replace the letters in this formula with the numbers given in the question. So F is negative, so that's 1 over negative 5, because it's a concave lens, is 1 over 10 plus 1 over V. Rearranging this, so minus in 1 over 10, I get that 1 over V is equal to negative 1 over 5 minus 1 over 10. Now negative 1 over 5 is the same as minus 2 over 10, if I just get a common denominator. So 1 over V is equal to minus 3 over 10, so it just allows me to add those fractions. Now you can either do a shortcut and just flip these, or we can cross multiply and get that V is equal to minus 10 over 3 centimeters. Okay, notice that we've actually got a negative number, and this will become important later on. Okay, so now we look back at our formula. We have our V and we have our U, so we can find magnification. So we know that M is equal to negative V over U, so 10 over 3 divided by, well, what was my U? My U was 10 centimeters. Okay, cancelling through by that 10, and our negatives are going to cancel as well. We get that our magnification is equal to 1 over 3. Okay, and that will be my final answer. So now let's just consider we've got a negative image distance and a magnification that's a decimal. Okay, so that's the same as 0.3 recurring. So we've got that the image size has actually decreased. So finally, the question asks, do your calculations support your ray diagram from part A? Well, to answer this, we need to look at 3 things. We first need to look at the image distance. Well, that was less than 0. Well, that implies to me that we form a virtual image. Remember, if the image distance is less than 0, we had to trace the rays back so they don't follow the natural path of light. So you have a virtual image. Next, we need to look at the magnification. Well, that was positive. Well, that tells me that the image was upright. then finally, we need to look at the size of the magnification. So I'll say the magnitude, this is how we resemble magnitude. Just put like a square at either side, a straight line. The magnitude of the magnification was less than 1. Well, that tells me that the image was diminished. And if you look at our ray diagram, all of these three things agree with our sketch. Now, let's just explain that last point slightly more. So this is some notation that you learn in A-level maths. But all it means is that m is between 1 and 0, or m is between -1 and 0. So in other words, m is 0 point something. M is 0 point something. Okay? So for example, if the magnitude of m is less than 1, then m is 0 point something. And we know that, say for example, 0.3 times by x, well, it's going to decrease the value of x. But then say if the magnitude of m is bigger than 1, so it's going to be 1 point something. So let's say 1.3 times x. Well, x is then going to increase. So that's going to increase by, say, 30%. Okay, so now let's go on to another example. And this time it's for a convex lens. Okay, so an object is placed 7 centimeters in front of a convex lens. So convex lens, we know it has a positive focal length. If it's 7 centimeters in front, that must be our U. And we've got our focal length of 10 centimeters. Sketch a ray diagram to represent this information. So again, I'm just going to write down what they've given me. Oops. So U is equal to 7 centimeters. Focal length is equal to plus 10 centimeters because we've got a convex lens. So let's sketch in my principal axes, my convex lens. Let's draw in my focal point. Remember, either side of the lens. That's going to be 10 centimeters. And this time, the focal length is inside one focal length. Sorry, the object distance is inside one focal length. So U is less than F. So my object is going to be placed here. That's my U. Let's draw a parallel ray that gets refracted through the focal point. Let's draw my unrefracted ray through the center of the lens. Okay, well these rays actually diverge, so that means I need to trace back to find where the image forms. So where do the rays appear to meet? Okay, they appear to meet here. So we form a virtual image because the rays only appear to meet. Okay, so next the question says, calculate the magnification of the image. Well, again, I know I have two formulas for magnification, minus V over U. Again, let's not forget the negative sign. And M is equal to image height over object height. Now in the question, I'm given U. I'm not given image height and I'm not given object height. So I'm going to have to use this formula on the left. Okay, well, in order to use that, I need to find V. So I need to use the lens equation. So 1 over F is equal to 1 over U plus 1 over V. Replace the letters with the numbers. So 1 over positive 10, because it's convex, is equal to 1 over 7. Let's just check. Yep. Plus 1 over V. Rearranging, I get 1 over V is 1 over 10 minus 1 over 7. And I actually get that 1 over V is minus 3 over 70, which tells me if I cross multiply, I get that V is equal to minus 70 over 3 centimeters. Okay, and we've got a negative, which makes a lot of sense because from our ray diagram, we got a virtual image, and we know virtual images are formed with a negative image distance. Okay, that makes sense. So again, let's substitute that into our magnification formula. M is equal to minus, let's not forget the negative, minus 70 over 3 divided by my U, which was 7 centimeters. Okay, so I can divide by divide by 7, cancel my negatives, and I actually get that magnification is equal to 10/3, and it's positive. Okay, and that'll be my final answer. And then it says again, do your calculations support your ray diagram from part A? Well, I know that my image distance is less than 0, which tells me I get a virtual image. Okay, does that support my ray diagram? Yes, because that's what I drew. Next, I know that the magnification of my image is bigger than 1 this time. So the size of the magnification is a decimal larger than 1. So in this case, which implies that it's enlarged. So what I mean by this is that in this example, let's do it in a different color, m is equal to 10/3, okay, which is equal to a decimal bigger than 1. So it's 1 point something. Previously, magnification was equal to a decimal less than 1. What was it? 0.3. So if you times something by 1 point something, it's going to get larger. If you times it by something less than 1, it's going to get smaller. Okay, so that tells me it's enlarged. Next, I have that my magnification was in fact positive, which implies that the image was upright. Let's look at my ray diagram. We've got an enlarged image that is upright and virtual. So yes, it does agree with my ray diagram from part A. Okay, here are 2 more questions. If you'd like the solutions, just email the words lens solutions to info@canarytutoring.com and I can send them over to you. And here's the second question.